Howdy, 8th grade. Today we are going to be working on multiplying some radical expressions. So we've worked with a lot of this before, just with normal numbers. We're going to make it a little bit harder by throwing in some variables, which should make it a lot of fun. But I think this is some stuff that we've already looked at, so it shouldn't be too terribly bad. So just kind of to review, when we simplified radicals, what we did was we took a number like the square root of, let's do 125. And we would factor this into the square root of 25, and the square root of 5, root 5, and root 5. And so then I would be able to say square root of 125 equals root 5 times root 5 times root 5. And I know the square root of 5 times the square root of 5 is just going to be 5. So now I can say this equals 5 root 5, which I know is a lot of steps, but I think that we got it pretty well. So it seemed like we were catching on to this fairly well last time we did it, where we just split this up into different factors. We're pretty good at factor trees. We get a 25 and a 5. 25 goes to 5 and 5 there. And then we can put it all back together. So our three factors multiplied together will give us our original thing. And if we have two square roots multiplied together, we get the number inside the square root. So the square root of something times the square root of something is just that something. So root 5 times root 5 is 5 right there. So with that knowledge, we kind of assumed something without saying it straight out last time, that if I have two square roots, we can just multiply what's inside. So multiplying square roots is the same to multiplying their insides. So just a real easy, quick example of that. That means I have the square root of 8 times the square root of 2. That's the same thing as saying the square root of 8 times 2, which is the square root of 16, which is 4. So if we have things like this, we can break them apart or just multiply them back together. The multiplication works the same outside the square root as inside the square root, which is going to make our lives a lot easier. So why this works is we're going to start with some number, and I'm going to call that number a. And a is going to have to be equal to the square root of a times the square root of a. That is how we define square root. This is what a square root is. This is what square root of a means. So the question now is, why would these things be able to multiply together? And the answer to that is, if I have b, that would mean that square root of b times square root of b would equal to b. I have ab would have to be equal to square root of a times the square root of a times the square root of b times the square root of b. So I'm just substituting what I had for b here down here, what I have for a down here, and I end up with this long equation. Or I could see this as ab as a whole thing would have to equal root ab times root ab, and from that I can see that root a times root b times root a times root b equals root ab times root ab. And from this it should be pretty clear to see that the square root of a times the square root of b equals the square root of ab. And y'all are going to be seeing a lot more of things that look like this when y'all go into geometry. This is kind of a real quick proof of why we can multiply these things together. So all I did was I said, if we have two numbers, I can define what the square roots mean, and I can write them two different ways. And if we write them two different ways, we can prove that multiplying square roots on the outside is the same as multiplying square roots on the inside. And that's basically all we're going to be doing this time. So if I have, one of the harder problems from this lesson is just using this with the distributive property. So the square root of 2 times 3 plus the square root of 6. I would be able to distribute this here. I have 3 times the square root of 2 plus square root of 6 times the square root of 2. And I know that root 6 times root 2 is going to be the same as, actually write a 3. 3 root 2 plus square root of 6 times 2, or 3 root 2 plus the square root of 12. And once I have this, if I wanted to, I could look at 12 and I could factor it and get a 4 and a 3 and a 2 and a 2 and just keep on going with this. 3 root 2 plus, this would be root 2 times root 2 times 3, root 3, and these are just going to give me 2, so I end up with 3 root 2 plus 2 root 3. Sorry I'm writing this so big, I'm just kind of breezing through it because I know we've looked at this before. So again, the big things we have to remember is if we have two things under a square root, that's just going to give us that thing without a square root. And other than that, we should be good to go. It'll be a lot of distributing and doing things we've seen before. So this shouldn't be too bad. Make sure you do the lesson practice, and I will see you all tomorrow.